Good morning, good afternoon, and good evening, and welcome to the Friday talk show of Global Electronics with your host Rajiv Kulkarni. This is 8 a.m. Central Standard Time of US and 7:30 p.m. of Indian Standard Time. Today is Friday, the December 12th, 2025, and today we have a special guest from the United States. And as you know, we have already published about them in our YouTube link as well as our YouTube poster, the event poster. So to mention about today's topic, singulation of printed circuit boards. It refers to the process of separating individual boards from a large array or panel. There are different types of methods and the benefits and the design requirement and the consideration which are engaged while you singulate the PC boards. So today's topic is being discussed with Mr. Klaus Heimann. He is the president of FKN SYSTEK, which is based out in Massachusetts in the United States of America. Mr. Klaus, welcome to the show and good morning to you. How are you this morning, sir?
I'm pretty good. It's a little bit early for me because Fridays we usually don't work on Fridays. We work from the office, but from home.
Okay.
But, I'm doing fine.
Oh, that's great. That's great. That at least it's a good time for you to, attend the show and discuss about your company as well as yourself and tell us about, singulation of PC boards. So, Mr. Klaus, first of all, thank you very much for attending the show and agreeing for participating in the show. And can you tell something little bit about yourself before we get on to our question and answer session?
Well, I was born in Germany and I came to the United States when I was 9 years old. So I'm one of the people that Trump can't kick out of the country. I hope. um, we established FKN SYSTEK in 1996, so we've been in business for, what is it, 30 years now?
Almost 30 years, yeah, 29.
30 years, yeah. And we've developed a number of new products since then. The special one, the best one we have is the K5000, which is a multiple blade depanelizer for high volume printed circuit board depaneling. You can do up to 10 panels in one shot. So people who do LED lighting do millions of boards a year with this machine. You can see that on videos of that on the website.
Okay, that's very good to know. And now tell us what exactly is singulation and why it is necessary in the PCB.
Well, printed circuit boards are made by running them through a reflow oven, and there's a certain size. They're usually 12 to 14 inches wide, and they can be about as long as they want to be. But when somebody makes a printed circuit board, some of them are sized about the size of a quarter or even a penny. So it doesn't make sense to send something through the reflow oven that size one at a time. So they do it in a panel, and they can do up to 25, 30, 50 pieces in one board. Here's an example of one. Here's an example of a panel.
Oh, okay.
1, 2, 3, 4, 5, 6, 7, 8, 9 panels in one. It's about 8 inches wide. And when they come from the reflow oven, after the components have been placed on it, you want to separate the board so that you can use them. The board that they actually want is just one of these right here.
Yeah.
Small size. So then they send this particular board is a nice design. It's both routed and scored, so that when you do a scored board, you can just cut the score line and it splits the board apart. That's probably the fastest way for cutting a printed circuit board, separating a printed circuit board after it's assembled. So you can see that kind of board being cut on the machines that you're showing up here on the screen.
Screen, yeah. So basically, what kind of common methods are used in singulation?
Well, there's two ways to make the board. One is to do a tab routed board. You can see this one right here.
Yeah,
There's
yeah,
even more boards on one panel.
right.
And in this case, if you do a tab routed board, you can punch or finish routing the individual panels. Now, finish routing is a kind of a slow process. It takes a while, but it has a
Mm-hmm.
very nice finish on the edge. And if you punch it, it's a lot quicker. There are some punches that will do an entire board in one shot, and those cost about $50,000. They're fairly expensive. But if you're doing small volume of boards, like 50 or 100 or 200 boards a day, it can make sense to just cut them out individually. And so those are the two main ways of doing a panelized board. One is to pre-score them, and the other one is to tab route them. And we have two ways of separating them. The pre-scored boards are separated by running it between two blades and along the score line, and it splits the board. The FR4 is a fairly brittle material. So when you put pressure on the score line, the board will break apart. You can see videos of
Okay.
those machines on the website.
What's your website, Mr. Klaus?
FKNSYSTEK.com.
FKNSYSTEK.com if somebody wants to
Yeah.
know more about the singulation and about the company FKN SYSTEK. So you can go to their website, fknsystec.com. So what kind of advantages and disadvantages that we see in each singulation method?
Yeah. Well, I didn't finish the different ways of doing this. Probably about
Okay,
five ways of doing it. One is to
okay,
use a circular blade to cut the pre-scored boards. The other one is a punch or a router for the tab routed boards. You can also use a saw if you want to, if you need to have a real good edge finish, or if you have components going over the top of the line that you want to separate, you can use a diamond blade saw. And, and those, I've got that on the table here somewhere and find it. But those are very thin blades and they make a very nice cut. One of the machines we made for a military customer here locally that's been in operation for over 20 years now. And
wow,
the only thing they've done is replace the blades 3 times in those 20 years. And that particular machine cuts about 10 score lines or 10 lines in one pass. The other way that in the past people have separated the printed circuit boards for V-score just by splitting them by bending them, which is not a good way to do it.
yeah,
For
I
instance, like
agree
this,
that.
if you go
Yeah,
like this, you can crack it like that. But
yeah,
it's a lot of stress on the board if you have components on the edge,
correct.
especially chip capacitors that are very sensitive to pressure.
Yes.
So for that, it's better to use a singulation blade like the K3000 or any of those machines.
So you mentioned that one of the customer have changed the blades in the last several years, 3 times only. So does that mean that the blades have that kind of life expectancy, like they can go on and on and on?
And those are the diamond blades for the saws.
Oh, okay.
The circular blades wear out because FR4 is a very harsh material. It's got fibers in it, which is like sand, and
Yeah.
that wears the blade out, so they get dull after a while. We can resharpen blades about 2 times, and they have to be replaced like once a year, probably 6 months to a year. They'll last if it's high volume production. For low volume production, we've had customers who haven't replaced a blade in 5 or 10 years. They do very few boards, but it doesn't wear them out.
So what there's a question asking about the advantages and disadvantages of each different singulation methods.
Well,
Would you like to give any examples on that?
well, Gabe, one, the
Yeah, one
of
is
doing this one is
yeah,
that
yeah,
it costs nothing except the broken boards and chips that you break. That's the disadvantage of that one. The
right.
advantage of the circular blade method is that it's the fastest way to do it because you can cut up to 6 score lines or up to 10 score lines in one pass if you use a K5000.
Wow.
Routers, finish routing, the advantage of routing is that it's a low stress method on the board. So if you have a tab routed board, you can put the components somewhere else besides where the tab is. But it's slow because you know how fast a router is. You just do one tab at a time.
Yeah, right.
Uh, and it also makes some dust. We also have a benchtop router, which can be used for low volume production. Uh,
Okay.
that's priced in a range of $10,000 or so. But
Okay.
a lot of military customers have used those. We've got about 20 of those out in the field.
Wow, that's great. And what other types of singulation methods you have? FKN SYSTEK.
Well, we have the saws,
Yeah.
we have the circular blade depanelizers, and we have a tabletop router, and we have punches. The N100 and the N200 will cut the tab on a tab routed board fairly quickly.
Okay.
Probably the least expensive way to do a tab routed board, if it's a rectangular board, is the N100. That's under $2,000.
Oh, that's so low cost, I would say. And these your machines are manufactured here in the USA, or?
Everything is made here in the USA. We've designed the machines here and we manufacture them. Some of it we do in-house. A number of other parts that we have machined in volume, we just send out to a company like Xometry or somebody. And
Oh,
you can't make everything.
so there is a question uh, asking about the preemptive design rules to observe to avoid SMT components, connector joints, and multi-layer circuit features when paneling rigid multi-layer board assemblies.
I didn't hear that. What was that?
It's they say that can you suggest some of the preemptive design rules or
Oh, the
are
design rules. Well, one of the design rules is that if you have uh, ceramic chip capacitors, very sensitive ones, you have to stay a certain distance away from the score line. And the spec for that is on all of our data sheets, and it's on the website too. Actually, I wanted to maybe do a shout out for
or a sample or something if you have.
yeah. Um, we don't. We just make the machines. We don't really have experience
In
in
the
what
design.
happens after people are using them.
Yeah.
The SMTA Association has specs for that. And
Yeah.
if you go to SMTA and get one of their books and it'll show everything. I think I have a link of that on my website somewhere too.
Yeah. So are there any special rules for panel design for IMS boards?
I'm not that into the design
Design side of it.
like that.
Okay. Okay. Yeah. Yeah. Let's forget about the design side of it because there are individual bodies like IPC, SMTA, and other
Yeah,
people
yeah.
who are engaged in the design aspect.
Yeah.
So I think
Next time we talk, I'll prepare something on that.
no problem. This is a question which has come to. And how do you optimize the PCB layout for singulation?
Well, it depends on the kind of board you're doing. If you're doing a small board, like this one, for instance, the way they optimize that is to get them as close to each other as possible. And if it's a funny shape board,
Hmm.
you can take a closer look at it like that.
Yes.
They can route the whole board out in the shape that they want. And in this case, the optimization was done that they routed it and then they put a score line along each side of it, so that when they in order to cut them, you don't need the expensive punch. You can just use, you could, on this one, you could do it on a K5000 where you could run the board through straight and
Mm.
cut the whole batch of them in one pass. It would take about 30 less than 20 seconds for one board to go through. But
Wow.
that would keep up with anything you can do on the reflow line.
Wow. So, what kind of common defects are the issues which can occur during singulation? Excuse me.
The most common defect that you need to be careful about is that if you have a ceramic chip capacitor too close to the edge, when you're running a circular blade, when you're running the circular blade across the V-score, it's like a boat going through water. There's a pressure wave going into the board. And a ceramic chip capacitor, the pressure wave will pass from one end to the other. And what happens is one part of the chip capacitor will lift a little bit, and they can cause cracks. So when you design a board, you want to keep the chip capacitors or any other sensitive component a little bit further away from the score line. Or if you can do a tab routed board with a score line mixed, and then just put the tabs where there are no sensitive components.
Okay, that's a wonderful response, I would say. So, are there any quality checks need to be done after singulation?
Well, you should, when you check the process before you put it into place with singulation, you should do some quality checks on the how good the chip capacitors are, or anything on the edge of it. I mean, obviously, anytime you put a board through a process, you want to check out afterwards that the process hasn't damaged it. So whatever standard quality checks you're doing, you can apply those.
Very nice, very nice. So, what is the typical lead time if somebody wants to order a machine from you?
Well, most of the standard machines like the K2000, K3000, K4000, and the nibblers are on the shelf. So we'll ship them
Okay.
out the next day.
Oh,
If they want a multiple blade machine like the K5000 or a custom saw like the S300, that can take, for the K5000, the typical lead time is about 1 month. Because
okay.
we put a few of them on ready to go, but the tooling has to be made for each type of board.
Correct, correct.
Cartridges
To-
have to be made.
Okay, so basically the maximum is like 4 to 6 weeks, I would say.
Yeah.
Okay, okay. And your company is located where?
In Boston, in Millis, Massachusetts, which is a suburb of Boston. It's about 15, 20 miles outside of Boston.
Okay, great, great. And how competitive you are when you compare with the other products from Asia?
With Asia, it's hard to tell because nobody calls us and says we bought something from China. I think we're pretty competitive. The main issue really is after sales service. These machines require circular blades, and we have them on the shelf. We also do blade resharpening for the circular blade depanelizers. And for spare parts like blade guards, or if somebody needs a new motor for a machine, we always have those on the shelf. And we've had some customers who bought machines from somebody else, and it took them 6 months to get a part to get that going again, which is not good.
Right. So that's pretty good, I would say, because I
And
think.
one
Yeah,
other
go ahead.
issue I'd like to point out is the fact that we're manufacturing and designing here in the United States. A lot of the depaneling processes may require some extra tooling, like the one that you just saw on the XY table on the
Yes,
K2000.
yes.
And we can work with our customers to make special tooling for them so that they can solve their depaneling problems.
Wow, that's fantastic because I think your main advantage is you're based here in the US itself. So for the US based customer, it is like, next door,
Yeah, that's
the
true.
availability. So that's the biggest advantage. And
Our German customers too, we all speak German.
There you go. Yes. And another thing I wanted to check with you is you what kind of market segments you cater to, like military, you mentioned, any other like market
Well,
segment?
for the routers, actually anybody who's making assembling printed circuit boards, and
Okay.
companies like Hewlett Packard, some of the larger ones, um, mostly contract manufacturers.
Hmm. Oh, that's very good to know, because then contract manufacturers users, they,
Oh yeah, we have a lot of customers who are contract manufacturers. Companies like Raytheon
yeah.
buy from us too, so a lot of military customers too.
That's excellent. I think those are some of the questions, Mr. Klaus, we have for today. And
Okay.
I think it's a very good explanation that you gave about FKN SYSTEK and your company. And so, would you like to say any few words for our audience?
Well, if somebody wants to take a look at how some of these machines work, we have videos of all of the machines, K5000, the nibblers, the routers, and in some of them, you can actually see me when I was 10 years younger. It's been online for quite a while. We've been in business since 1996, and we have probably around 400 or 500 customers who are studied contract manufacturing, military, most of the larger electronic manufacturers in the United States. Uh,
Excellent.
and I mean, we're here. I check my emails every day, even on the weekends. So if anybody has any problems, we respond instantly.
That's a very good approach, I would say. And I think that also makes it easy for the customers to address their issues
Mhm.
and and get back to you, or you getting back to the customers will make them feel very comfortable in terms of doing business with you. With that said, thank you for your time again, Mr. Klaus, for giving your valuable 30 minutes to us today. And so, Global Electronics' main objective is to support the electronics community in the electronics manufacturing subject. Whether it can be process related, whether it can be quality related, whether it can be market related, or the equipments such as the singulation of PCBs or routers or laser marking and so on and so forth. So, Mr. Klaus, have you thought about getting into any laser depending activities?
Um, Laser, I don't see that as being much of a competition because it's kind of a dirty process. When you burn through a printed circuit board, you have to remove the smoke and the dust
Smoke,
from
yeah,
that.
yeah.
So the one thing I may want to expand in is to have some more automated routers available for people. Oh, one
Okay,
last thing. I just want to do a shout out to Vern Solberg at Solberg Tech. In case I don't know, I'll put this up in case anybody can see it. Um,
okay,
put that guy's name on the website. He came by the SMTA show last week. He actually
okay.
printed a very good book about uh, PCB manufacturing, and it's got
Ah,
information. It's got information about what's required for depaneling. The other place you can find information about depaneling or PCB specs for depaneling is the SMTA organization. They have printed a book that has all those specs in it.
yes, they have a lot of technical journals available on
Yeah,
the
yeah,
website.
yeah.
And since I'm also SMTA active member and also serving the SMTA India chapter, so I'm a VP of membership of India chapter, and we welcome for the audience to become SMTA member, and so that you can find these journals available for you on their website. So With that said, thank you again, and Merry Christmas in advance to all of you, and have a wonderful weekend. And thank you again for watching the show with your host Rajiv Kulkarni on Global Electronics Friday Talk Show. We'll see you next week at the same time with yet another topic, very interesting topic. So stay tuned with us. Have a wonderful weekend. Bye now.
Hmm.